All right, let's talk about Python. For years, developers, well, we've all been bumping up against this one big wall, right? The big performance limit, especially in a world of multi-core processors. Well, what if I told you a new project claims it hasn't just chipped away at that wall, it's completely smashed it to pieces?
And just listen to this statement. Wow. I mean, that's not just some minor improvement, is it? That's a bold declaration that the old rules of Python performance are basically obsolete. This is the central promise of a project called protoPython, and we are going to dig in and see what this could mean for anyone who's ever just wished their Python code would go faster.
Okay, so let's back up a bit. We all love Python for its simplicity, its incredible ecosystem. But, and it's a big but, when you need raw, multi-core speed, there's always been this hidden bottleneck. It's kind of like having a super fast highway that suddenly narrows down to a single lane. No matter how powerful your computer is, everything just slows down.
And that bottleneck leads to a question that I'm sure has driven so many of you crazy. You've got this machine with 8, 16, maybe even 32 cores, and your complex Python app is just stubbornly chugging along on a single one. Why? Why can't it just use all the power you paid for?
Well, the culprit has a name, the Global Interpreter Lock, or the GIL as we all know it. So think about that superhighway again, right? Your multi-core CPU has all these lanes ready to go. The GIL is like this tiny one-lane bridge that every single thread has to line up and cross one at a time. It's this fundamental lock that just stops standard Python from doing true parallel processing.
So what if you could just, demolish that bridge and build a proper multi-lane superhighway in its place? Well, that's pretty much the whole idea behind protoPython. This isn't some little patch or a tricky workaround. We're talking about a complete, GIL-free version of Python, rebuilt from the ground up for the exact kind of multi-core machines we all have today.
So let's get specific. What problems does this redesign actually solve? On the left, you've got your classic Python headaches. The GIL, obviously, that's the big one. But you've also got the constant risk of bugs when different threads start messing with the same data. And if you're in data science or AI, you know this pain. Copying massive data sets over to C++ libraries, it's just so slow. Now look at the right. protoPython's answers. True parallel concurrency, no more GIL. Immutable core integrity, that's a fancy way of saying data can't be accidentally changed by different threads, which just wipes out a whole category of nasty bugs. And zero copy interop, that means no more waiting for data to copy. You can share info with libraries like NumPy or TensorFlow, instantly. And this is maybe the most crucial point. You might be thinking, great, another language I have to learn. But no, this isn't a brand new thing. It's a high-performance engine designed to run the Python code you're already writing. And by aiming for full compatibility with future Python versions like 3.14, the goal is for it to be a simple drop-in replacement. You just swap it in, and your existing projects get a massive speed boost. No huge rewrites.
Okay, so a GIL-free Python. It sounds like a dream, right? But how does it actually deliver on that promise? Let's peel back the layers a bit and look at the architecture and, how far along this project really is.
And let me tell you, this is not just some idea scribbled on a whiteboard. Take a look at this status table. The project's in phase 6. The core runtime, complete. That super important C++ interoperability, full. Compiler, advanced. But look at that last line. A 100% test pass rate. That tells you this is a serious, well-engineered project that's being put through its paces. So what's the secret sauce here?
Well, it comes down to a few key architectural wins. You get true parallelism because every Python thread is now a native operating system thread, no more faking it. As we mentioned, making data immutable by default is a game changer for safety in multi-threaded code. It's also hardware-aware, which means it's optimized to use modern CPU caches efficiently, a huge deal for scientific computing. This is the kind of architecture that could unlock new levels of performance for AI model training, massive data analysis, and high-traffic web servers, all in Python.
So we've talked about what protoPython is, but the story of how it was built is honestly just as fascinating. This wasn't created by a massive corporate team. It was built using a new method called the swarm of one. And this quote is key. This isn't about an AI mindlessly generating code. It's about a single human architect defining the vision and the core design principles and then using a swarm of specialized AI agents as a massive force multiplier to execute that vision.
Here's how that process works. It starts with a human vision. The architect lays out the blueprint. Then, a whole swarm of AI agents accelerates the incredibly complex work of implementing that design. Think of it like a master architect directing a team of 1,000 specialized, tireless builders.
The result is a project of this scale, a GILS Python runtime, built in a fraction of the time it would normally take.
So, protoPython represents a potential seismic shift in the Python world, both in what it is and how it was made. And now, for the really exciting part. The project is opening its doors to the community.
This is the call to action. The core components, the runtime itself, along with protoPy the interpreter and protoPy the compiler, are now open for public review. The project is inviting developers to examine the architecture, push its performance to the limits, and provide the critical feedback needed to get it ready for prime time.
This brings us to a final thought. A GIL-free, high-performance, parallel Python has been a dream for decades. According to its creators, that future is here, in code that's ready to be tested. The only question left is, will you help build it?